Hi, everyone. Uh, it gives me a great pleasure to welcome you all to the September meetup of Women in Compilers and Tools meetup series. It's my honor to welcome Dr. Teresa Johnson as our highlighted speaker of the month. Teresa develops compiler optimization techniques at Google currently. She is an active contributor to the LLVM open source project and has designed Thin LTO framework for scalable link time optimizations. She also, prior to working at Google, she developed compiler optimizations for the Itanium compiler at HP, and she received her PhD from the University of Illinois at Urbana-Champaign in 1998. Besides her contributions to the compiler development, she has also served in various program committees and steering committee at several different conferences. So we are very humbled to have her here today and very excited to have you today. And today's session is going to be a lot more exciting and engaging because it's not going to be a tech talk. Rather, you have an opportunity to ask questions from our speaker today. So please feel free to ask the questions directly or post them in the chat window. And by the way, I just remembered that today we complete 6 months of our Women in Compilers and Tools meetup series. So that's a lot more exciting for us as well. And thank you to all the attendees who have been coming and giving us a great support. And thanks, of course, to our speakers who have always been here sharing their knowledge and insights with all of us. So thank you, Teresa. It's
Thanks for having me. Yeah,
yeah, it's
I'm
our
happy to
honor
be
to
here.
have you. Thank you. Okay, so I think to get started, probably I can start with some questions and then we can
Sure,
see how attendees, post their questions and how that goes. So
sure.
I think the first thing I'm very, very curious to find out in general. I have a very little experience in compilers, and there are a lot more in the audience today who also have a lot of more experience than me. But I personally wanted to find out, how did you navigate your interest towards learning compilers and specifically in the compiler optimizations because it's harder to find out more people who work on the optimizations in particular.
Yeah. So my undergraduate and also my graduate degree are actually in electrical engineering. So I kind of came toward to compiler optimization through computer architecture. So when I was in my undergrad, I got really interested in computer architecture and ended up working in that space during graduate school. And we were doing, in my research group, we were doing um, epic architectures, which is like what Itanium was. It's like explicitly parallel instructions. What is this? Instruction commutation. But it basically is statically scheduled architectures. And so there, the compiler becomes really key to performance. And so my research group, which did computer architecture around that kind of model, we also developed our own research compiler to actually compile for it because you can't really show good performance on that kind of architecture without actually having sophisticated compilation techniques. So we were doing, we had people in our research group who were kind of doing architecture and compilers and, like everything in the range across those two things. So my graduate research was actually, my thesis was on cache, was like runtime adaptive cache hierarchies. And so it was more, my thesis was actually more on the architecture side, but basically everyone in the group worked on, and contributed to this research compiler. And so that's really where I got my compiler experience. My initial compiler experience was just contributing to that compiler and also just reading a lot of papers. So, it wasn't, I didn't come to it from like just studying compilers as in school in class. I came to it more from sort of practical side in graduate school, actually working on it and then learning what I needed to learn by reading papers and just hands-on work. So that's kind of how I got into compilers. And then when I finished grad school, I actually interviewed for both architecture, microarchitecture jobs, as well as compiler jobs. And this was kind of this was in 1998. And it was when they were getting ready to, I think they were getting ready to maybe tape out their first Itanium implementation. And for Itanium, which is statically scheduled again, the compiler is really, really important. So at that point, I kind of decided that actually compiler jobs seemed maybe a little bit more interesting to me because there was so much to do on the compiler side. So that's kind of the direction I went, and then I've kind of stayed, in the compiler space ever since then.
Yeah, that's pretty exciting, and especially the fact navigating through the computer architecture research and eventually falling into the compilers. Like today, when we implement compiler optimizations, now it's the need of an hour. That we have to know even a lot of hardware features and a lot
Yeah,
of architecture details to actually achieve that kind of performance for the backend. So that's
it really helps, I think, to have knowledge in both spaces and what's actually happening in the underlying hardware, and then also then how you compile for that. So
that's
yeah.
fantastic. Yeah, great. And when you were finishing your grad school, what was a vision that you set for yourself for the upcoming years, or decades,
Mm-hmm.
And how do you feel coming along this long way in your journey?
Yeah, so I mean, I felt that I knew I didn't want to do academia. I wanted to be in industry, but I felt that I wanted to, my goal was to basically do something innovative and to, become like a technical lead. And I have always known about myself that I don't want to be a manager, and I have so far managed to avoid that. Strenuously pushing back on opportunities as they arise. So I'm an individual contributor. I'm a tech lead in my project, and so and that's kind of the goal. I mean, I wanted to do interesting technical things and kind of rise up that technical ladder. Um, and I also, when I finished grad school, I also I got married around the time I finished grad school, and I wanted to have kids, and I also wanted to, have find the right balance between, you know, parenting and also working. And I mean, I feel, now I've been in my career I've been out of grad school for 20 something years now. Um, I mean, I feel like I've done pretty well in accomplishing those goals. I mean, I still feel like, you know, I'm still learning and growing, and often feel like I'm kind of bumbling around, but that's I feel like I've pretty much been able to accomplish a lot of the things that I wanted to.
No, absolutely. We admire you so much as a whole group, and there's no,
Oh,
we
thanks.
don't have a single, you know, second thought on your accomplishments. And this thing, I think, came up in one of the events earlier also, where very proudly mentioned this fact that you knew how to make a balance between your parenting and your work life, and then also choosing the career to be an individual contributor, because sometimes by our choice or by our situations, we tend to take different directions, like, okay, maybe this is the time
Mhm.
when I can move from the individual contributor to being a manager for a while and then come back to this and so on.
Mhm.
So it's really admirable in a way that you have chosen the things that you want to do and yet being able to manage it so well. So I think I would just shift from there a little bit on finding out a little bit more
Oh,
about
thanks.
how easy was it for you, at that time? Like, yes, today there will be different challenges, sure, right? It's been more than 20 years for you, ever since you finished your grad school and so on. But I
Mhm.
think when we are so new to the career, it just feels very different. In a way, we have a fear of being judged by people, and we also ourselves don't know that
Yeah.
how should I prioritize my own uh, priorities in front of people and say it out loud that, okay, this is something I want to focus on. But we also have a fear of losing out on a lot of things. So can you share something about that?
Yeah. Let's see. So, well, I just want to go back to one thing. I mean, like, I feel like the balance I found is always very tenuous, and maybe I'm glad it like worked, you know, it's like I would say that I took my work life balance in like a year by year kind of, um, you know, I have to take things kind of year by year, and I'm always, it's always a work in progress. So I mean, um, I feel like I've done a pretty good job of that, but it's it's not easy, and you always wonder, like, are you prioritizing one versus the other? So that's one thing I wanted to say. But let's see, in terms of starting out and asking questions, and then I think I forgot. Sorry, I forgot the second part of your question.
Yeah, I think my first question was like, how did you, seek help, or how did you actually, go out to maybe to your managers or to your leaders up there and
Yeah,
say, okay, this is the thing that you're going to focus on, and maybe this is how you want to balance
yeah,
and so on. Because figuring out a balance in itself is harder by yourself, and then
right,
asking for help is another thing. And
right.
how did you approach people about that?
Okay. So yeah, I mean, in terms of getting help, I mean, I think that I mean, I think it helps to so I really valued, I think, when I like, for example, when I started at HP, like, forming bonds with people that you sort of build up this level of trust with the people that you work with, where you feel comfortable approaching people for help. And I think the thing I've learned throughout my career is, like, nobody is an expert on everything, and there's certainly things that I know now that I didn't know before, but there's things that I knew before that I have forgotten. So just I have to remind myself sometimes that, like, you know there's no way I'm going to know everything, and so it's good to know who to approach, who might actually have the expertise in the area that I need to gain some knowledge in, and build a connection with them. And a lot of times, uh, it's like a give and take. I mean, if you approach somebody for help, a lot of times, on technical things, a lot of times, in the end, you, like, when you build that relationship with somebody, then it becomes sort of symbiotic. You can also share your knowledge with other people. Um, so so that's one part of it. I mean, I would say, like, when I started at HP, also, there were a lot of people who I really admired. There were a lot of women, actually, who worked there at the time, who had a lot more expertise in what I was working on at HP. So, like, uh, Uma Srinivasan, who talked here earlier, Carol Eit, and Ann Holler was another woman there. And just, it really, I think for me, it was maybe a little bit less intimidating to talk to another woman when I had technical uh, questions. It's, sometimes you feel they're a little bit more approachable. And um, so that's one thing. And then in terms of sort of, I think the second part of your question was, you know, speaking up for basically what you want to do, and talking to your manager and stuff. And I think that, um, you know, I think it's good to be really clear in your mind about, like, what you want, and to really advocate for yourself. And so, like, for example, for me, I really don't want to be a manager, and that's something I've had to just, I'm certain about, and I've had to, like, be sometimes clear about what my goals are, and remind myself to basically speak up for what my goals are in my career, and my comfort level with different things. So I think it's important to really, I guess, advocate for what you want to do. So, for example, when I had kids, I ended up dropping down to part-time, and it was a little, I would say, intimidating to ask for that, because I didn't see anyone around me who was doing that. But I did ask for it, and I got a good answer. I mean, I was able to basically adjust my schedule the way that I wanted to. And so I think it's good to be sort of clear on what you want and what your goals are, and not be afraid to ask for those things, and to basically advocate for yourself. And um, yeah, that's
Yeah, thank you for sharing. I think it takes a lot of courage as well, personally, to be able to advocate for yourself. and to also
Mhm.
recognize that this is the thing that you really care for, and put it out. I think people wouldn't say no. I think we ourselves say no to ourselves a lot of times, even before we ask for
Yeah,
help. That's the most common situation we end up in.
yeah,
So
definitely.
it's important to be more courageous and to be more clear about our own goals.
Yeah.
Yeah. Thank you for sharing. Yeah, taking a little bit shift towards your technical contributions, I think, can you talk a little bit about the Itanium compiler? Like, what
Mhm.
were the contributions that you worked on during that time? And what were some contributions that you see today also in a lot of different modern compilers that exist to date?
Yeah. So one of the main things that I worked on when I was working on the Itanium compiler was data cache prefetching and basically handling memory latency. So Itanium was statically scheduled, and so you had to basically schedule instructions um, to cover whatever latency there was going to be from the hardware. Otherwise, basically, the pipeline kind of stalled. So it was really important to when if you're going to have um, if you're accessing a lot of data that might miss in the cache, it was really important to either schedule the load far away from where you're going to use it or to actually issue software data prefetches. It was really critical for the performance. And so that was one of the main things that I worked on quite a bit in the Itanium compiler. Um, and another thing that I had worked on was, and it kind of related, was looking at using some like dynamic feedback to adjust the code, basically to do some runtime optimization. Again, similarly trying to handle uh, these latencies that basically you couldn't necessarily predict when you were compiling statically, but try to adjust the code to do something to basically schedule things a little bit differently at runtime. Um, and in terms of, so I think one of the interesting things about Itanium, I mean, when I switched to Google and we were targeting x86, it was very different because it's out of order. You didn't have this sort of static scheduling issue. And so it sort of naturally handled things like cache latencies a little bit better. You didn't have to be quite as careful about how you scheduled things. Um, so it was a slightly different problem. But I think that, in terms of some of the work that we've done that has kind of influenced current compiler work. One of the things that was really important for Itanium was because we had to schedule things so carefully, we used a lot of profile feedback. And I think that that's something that really, I think in general, because the compiler was so important during Itanium, there was a lot of people working on compilers, and there was a lot of just sort of broadly general, not even Itanium specific work, but sort of general compilation work that was developed during that time. And so, I mean, I think that was really one of the first times where I think compilers really started relying on profile feedback. And that's something that you see a lot today in, for whatever architecture and in LLVM and various compilers.
Yeah, that's true. So, a lot of times it's common to see, even till date, that compiler developers are investing a lot of time writing compiler optimizations, either specific to a particular backend or they're writing it for the IR. And now the focus has been shifted towards making more abstractions. Like, I think the focus has not just shifted now, it's been around for decades again. But now it has become another hot thing. Like, people have started to think about designing new programming models and so on. And now the machine learning has
Mm-hmm.
taken a different kind of a hot seat in compilers domain along with it and so on. But
Mm-hmm.
I I was just curious to find out, like, how your focus shifted towards particularly the link time optimizations, because link time optimization in itself, whenever it comes to the linking phase, it just sounds too complicated, and it's hard to find out people actually focusing a lot on designing optimizations for the link time. So what really motivated you to focus on that particular optimizations?
Yeah, and doing the link time optimization is still doing, essentially often IR based optimizations. It's But it's, one of the reasons one of the reasons we started focusing on link time optimization particularly. So in the compiler, in compiler optimization, basically one of the biggest performance levers we have is inlining of functions into another. You can get, it's results in huge performance wins because you basically, anytime you enlarge the scope of what the compiler and the optimizer can see, you can do more aggressive optimization. And so inlining is one really important way to do that. And, traditionally in the compiler, you're sort of limited to doing inlining in one translation unit. It's like one .cc file, you can optimize that pretty aggressively. But if you can actually enlarge the scope by, say, inlining from another translation unit or doing some optimization across different translation units, you can actually get much better performance. And so LTO is kind of a somewhat natural way of doing that. So the background on Thin LTO specifically is that so at Google, we used to use GCC, and we had like a public branch off of GCC, and we had a technique that was developed before I got to Google, that was built on this Google GCC branch that just kind of did like some basic enabled some basic cross translation unit optimization, and it did this. What's called LiPo. And it basically did this by, like, when you parsed your source file, it used some profile information to figure out like some other source files to like kind of parse in at the same time, if I'm making any sense. So it happened kind of very early in the compilation process, and then you would like basically, it was driven by profile information, you were able to basically pull in other pieces of code. So what this did is it enabled more aggressive inlining across translation units, and basically, again, enlarge the scope of what the compiler could see as it went through then the rest of this sort of very normal compilation. Mm-hmm. However, it was fairly brittle. Anytime you have a lot of limitations when you're doing this kind of code merging at the parsing level, at the front end level of the compiler, and it was driven on profile information, and that could sometimes, like, basically not only driven by profile information, but like the correctness was the profile information basically affected the correctness of how you did this. So it was always, there would be problems because, like I said, there was some brittleness to this. And so at one point, we were trying to figure out how to, we were fixing some issues, and David, Lee, and I started thinking about, like, out of the box, like, how could we come up with a different method? And we were sort of drawing on the whiteboard. Basically, you want this like small synchronization point, but basically still keep everything in parallel and not have to glom things together at the front end. And so that's sort of what became Thin LTO. And then going to, like, why is this LTO? So basically, at link time, you sort of naturally are like, if you think of a traditional compilation, you basically compile a bunch of files down to native objects, and then you link everything together. So the model of building files already sort of, when you do the link, you're passing in everything that you need to build together. And so the nice thing about doing these kind of optimizations at link time is it doesn't change the model in which you build things, because you're still building things down to a .o. It's IR instead of native, but when you do the link, then you sort of naturally, the build system just pulls in everything and passes it off to the linker. And if it's IR, you basically just, it knows under the table how to pull in the compiler and basically do the LTO optimizations. So kind of a long story of like, why LTO? Well, LTO because it's sort of naturally fits into the build model of, like, you're anyway going to, like, take all your object files and pass them off to the linker. So let's just do a little bit more there. And it doesn't actually affect the way things build from the sort of, when you look at it from a high level, you're still doing the same thing. You're still sort of compiling down to a .o file, and you're just passing everything to the linker. And then why Thin LTO is kind of basically a way of doing this link time optimization that sort of addressed some of the problems we had with our earlier sort of cross-module optimization framework, and basically Thin LTO is basically a much more lightweight way of doing LTO than had been done before. So kind of a long story there, but
So is the fact that Thin LTO has the tag thin in it that you actually slimmed down the real traditional link time optimization phase and rather, abstracted away the details of like, okay, using the inlining feature up there in the front end phase. So you do a lot of, complicated tasks up front even before it reaches the link time.
not really. It's not actually happening before. It's not actually happening in the front ends. It's still happening at the link level. It's thin because traditionally, link time optimization basically takes all these .o files, which are then, when you compile with LTO, they're all IR instead of native files, and it basically gloms everything together into one huge IR module and then does the normal compilation on it. And it's very expensive because if you have a large application, your IR, when you merge it all, is huge. So Thin LTO basically keeps the sort of the monolithic portion of it very, very thin, very small. So basically the way it works is that we have little summaries in all of the .o files, and the whole program, the piece only just operates on the summaries. It doesn't look at any of the IR, so it keeps it really lightweight. And then all of it sort of then farms everything out back to the individual .os, and the rest of the compilation can then be in parallel. So you still have to compile those IR files down to native, but you can do it completely in parallel with like basically the information of this sort of thin synchronization point that basically does summary based whole program analysis. And so it's still, it's still kind of hidden under the link process through all just different threads compiling things in parallel, but now they're in your link process, but they're, in parallel and kind of fed by this lightweight whole program. So
that makes sense. And I can also imagine like, coming up with this design is absolutely fantastic. It's, the response is in itself, so remarkable that people are actually using it and it has landed in LLVM compiler. So I think I also wanted to know, like, when you were designing Thin LTO in particular,
yeah,
how was the design being driven? Like, did you know upfront, like, okay, while we are taking this kind of a direction, maybe we are aiming for this kind of a performance percentage in terms of like, let's say the link time will be improved, or and so many other parameters that that we care about, maybe the code size reductions and so on. So like, how did you actually aim towards designing it? And there's another design question that I would ask later, but I think first I want to hear more about how did this idea was driven.
Yeah, so basically we wanted to keep the whole program part as like I said, as thin as possible. And still, when we were designing this, I mean, mostly what we got with like our older technique of LiPo is like this benefit of inlining. So we were really focused on being able to enable inlining across translation units. And so a lot of the design was very much focused on that initially. And, eventually, one of the benefits of doing it through LTO is you actually you have whole program information because everything is passed to the linker essentially. And so, it turns out you can actually do a lot more aggressive whole program optimizations where you basically, because you can see all of the summary of the entire code. So we were really focused on inlining it at first, and that was sort of like the main initial optimization that kind of shipped with the LTO. But people are still adding in new whole program optimizations, like David Blakey, who's on this call, was asking me about something that just went in that someone contributed to do some whole program propagation of, function attributes. So there's basically, it's sort of the nice thing is it's a sort of a framework that you can build other optimizations into. The thing that you have to be careful about though is, we need to keep that whole program step lightweight and thin, otherwise the model kind of breaks down. So you can't, there's always this tension between like, what information do you put there and what do you do there versus, compile time and you know, you have to be a little bit cognizant of not, basically, you don't want to reproduce everything that's in the IR into the summary, because then you lose all of your benefit. You want to be a little bit careful. So it's something that we had to keep in mind. You know, the other thing that I would say that was really interesting, and this is kind of has to do with, you know, the process of developing this in LLVM, was that, you know, we came at the problem with sort of like focusing on like inlining, and also in Google, we have a distributed build system. And so one of the things that we do at Google is, rather than, you know, I talked about how in ThinLTO you have this, like, it's all kind of hidden under the link. So the link does this thin whole program step, and then it farms up all these threads. In Google, what we do, because we have a distributed build system, we actually break those apart. And so all of those threads are actually separate processes and all get shipped off to different build machines. So we were very much focused on trying to optimize for, you know, these large builds and use our distributed build system. But actually, you know, one of the nice things about working in LLVM is that we ended up collaborating with people from other companies. So like Many, who was at Apple at the time, got really interested and ended up collaborating quite a bit with David and I. And so at Apple, you know, one of the benefits that he realized that you get with Thin LTO is, you know, because they're not using a distributed build system, they're using the sort of like the threading model of all these backends. One of the things that he pointed out is that you get a big benefit in terms of your ability to do incremental compiles much faster. So even when you're doing this all in the link process, you can still actually have a build cache, and a lot of those threads, you know, you can basically cache them and cache the results. And so basically what I'm trying to say is that, you know, like we came at it with one view of the benefits. And the nice thing about collaborating with the community is that you get other people involved who actually can like drive other aspects of the development that actually, you know, expand what this optimization framework can actually do. And
right. Yeah, I think that was my follow-up question anyways, on like driving this whole design of Thin LTO. Like, I just wondered, you know, when it has landed in LLVM, and since you started this work while working at Google, so, you know, were there decisions that were influenced because of your particular use case? You know, since Google itself has a huge use case, as you're mentioning,
Mhm.
that it's the whole distributed system space, and, you know, that kind of gave you a lot of ideas on how to actually design a Thin LTO kind of a system. So
Mhm.
were there any other, you know, decisions that you had to make? Or in general, I think the broader question is that when we are designing a new system or a new framework, you know, what are the, you know, design decisions that one has to make, in particular for those, you know, large softwares or programs
Mhm.
out there which are being used by a large number of users, just like
Yeah.
LLVM, right?
Right. I mean, you know, and when we first proposed LLVM, I'm sorry, Thin LTO to LLVM, it looked a little bit different because we had, you know, sort of our use case in mind. And I think the design evolved based on community feedback for the better. And, uh, you know, so in terms of, you know, designing, what you have to keep in mind, I mean, I think that it's good to get a lot of feedback from various users, because you get, you know, I think it can, you know, evolve your design to handle other use cases and be sort of more just more robust. The other, you know, things that we had to think about in Google is, so we, you know, integrating with the build system and how that would work. And so we spent a lot of time working with the people in Google who build the build systems, and like how will this work, and like, you know, how does it interact with incremental builds. And like thankfully there also it actually works quite well with incremental builds. But you know, in terms of, you know, I think things that we had to consider was like, you know, all of those pieces, like how does it work with the build system, you know, how will it work for other users of LLVM, and other use cases. Another thing we have had to think about quite a bit is how does it scale for tests. So basically, for tests, you have to be a little bit careful, because if you're linking your test statically, suddenly a big part of your compilation is no longer sort of shared across all of the tests that you're building. So you have to be a little bit careful about how things scale in this, world where you're like building tens of thousands of test cases. So, just being careful about in the build system, again, how things are built, and how it's integrated with ThinLTO has been really important.
Teresa, I had a question. So you mentioned that in some of the earlier systems, which were also a little fragile, you were using a bunch of profile information.
Mm-hmm.
So what kind of profile information was being used for performing these optimizations?
Okay, so are you like in the old system or versus
in the old system
now? Okay, yeah.
Or
so in the old system,
sorry. I mean, typically for doing this kind of whole program optimization.
Okay.
Yeah.
Okay, so the thing that we were doing specifically in the old thing is we were making decisions at profile time about which translation units we wanted to kind of glom together. And so it became basically almost like the correctness of the optimization became tied with your profile. You have to be very careful about using the right profile with how you're building things. In general, I mean, we still rely a lot on profile information, but it's more complementary now. So you don't have to have profile information to build with ThinLTO, but if you do, they sort of complement each other. So for example, one of the things that profile information drives, again, is inlining, which is a huge performance lever. And when we do ThinLTO, we're deciding at that thin layer, what functions we might want to inline from other translation units. And so it basically kind of directs the backends which pieces of code to pull in. And you can be a lot smarter about that if you have profile information. Because if you have profile information to basically pull in more of just the hot code and not the cold code, you spend a lot, you basically, you are, first of all, you're not, you're using your compile time more wisely. You're compiling more things that are hot together and less things that are cold. So yeah, I mean, we definitely rely on profile information to help guide intelligent decisions. Also, like for indirect calls, like if you have virtual functions and virtual function calls, they look like indirect calls. The compiler doesn't actually know statically often what the target of those are, but with profile information, you can actually say these are the likely targets. And so we can actually do some speculative promotion and inlining of those calls. So again, and then with ThinLTO, we can do that across translation units. So they basically complement each other.
Got it. Thank you.
I had a question, Teresa.
Sure.
One of the things that I found challenging as sort of an ongoing challenge of compiling is that people who, in particular, who work on, kind of back-end compiler optimization sort of things, their skills, like me, they lie sort of algorithmically and coming up with, algorithmic approaches to do these compiler optimizations, whereas things like LTO and actually other compiler challenges that deal with the need for cross-module information, it is much more a structural challenge of how you capture and represent, and in particular, you mentioned scale, all the data that you require. So, I found that my challenge was that just wasn't where my brain worked the best. And so it seems like you need to have some complementary skills in that sort of structural design realm, as opposed to just sort of the algorithmic skills that are really common among, optimization people. So I thought maybe you could comment a little bit about those different challenges.
Right. Yeah, I mean, and definitely I would say a lot of my career has spent doing a lot of that sort of algorithmic level compiler optimization. And so ThinLTO was very interesting because it affected, you had to think much more holistically about the whole compilation process. And again, like I said earlier, like how does this fit into the build system? So it's definitely a little bit of a shift, and you need to again think about, you know, the scaling of like what is the information I need to do those transformations, and how can I do that intelligently without, you know, blowing up that sort of whole program piece. So yeah, I mean, I definitely agree that there are slightly different things that you need to think about. So yeah, I mean, for me, it was definitely, it took some time to sort of like, you know, transition into thinking about how to structurally organize this. You know, we sort of had this very nebulous idea of what Thin LTO should be at the beginning, and like how to actually, you know, make that concrete and make the structural changes to do that. It took some time. I mean, it was gosh, I mean, we started thinking about Thin LTO in 2015, or maybe even 2014. I don't know, probably 2014, and it took, you know, several years of like us proposing it to LLVM, getting on the development, and then rolling it out, and then yeah, it's a long process.
Yeah,
Thanks.
Yeah, and I think the other thing too is like the time scale, and when you're doing something more structural, is a lot longer.
Yeah, I think the broader question that I also had, you know, with this pretty much the similar perspective and even a lot more general, was like, you know, after you have spent more than 2 decades writing compilers, and now we have Carol who has spent even longer.
Yeah.
Thank you, Carol, for joining us today. So, you know, after you have spent a long time writing these compilers, what are the changes that you have seen in particular with the whole landscape of compiler development evolving, you know, till date? Like, what are the things that have remained pretty much the same, and what are the, you know, changes that have happened, like the shifts have happened in the long time?
Yeah, I mean, I think the biggest change that I have seen is the move towards open source compilers, and that is like that's a huge change. I mean, when I started on grad school, we had our own research compiler. A lot of people did, and I don't know, you know, everyone now I think uses or builds on top of LLVM or GCC or one of the open source compilers. And you know, working in industry for a long time, it was all proprietary compilers. So I think there's been a really big shift towards, you know, open source, and like I mean, you see it in like the LLVM community, and I know GCC has grown, and being that also open source compilers being used in industry as well, and then in research groups. So that's a huge shift, and I think it's really good because there's so much information sharing, and you can actually do a lot more interesting things when you have like the actual really solid compiler infrastructure already there, and you don't have to build it from scratch. So that's one big change I've seen. You know, another thing I'll say is I find like an interesting that a lot of these problems I think are cyclical. So things, you know, I like talked about how back in the Itanium days, I spent a lot of time working on, you know, scheduling for data cache misses and prefetching. And then I came and worked at Next86, and it was like, oh, that's not even something we think about. All these other things that we, you know, are bigger problems and different problems. But, you know, I think that, you know, sometimes you see a shift back towards actually, okay, we need to start looking at, you know, data cache handling, what it becomes a bigger problem, basically because, you know, the nature of your applications changes, or, you know, you address some of the other problems, and now that becomes a bigger problem, or because, you know, architectures again change over time. I think one interesting thing that we're seeing is with like RISC-V and ARM, there's like so many different interesting custom processors, and I think you see like a lot of different types of scheduling. I mean, there's a lot of in-order processor implementations that people are doing, and a lot of, you know, they're going to have to think about a lot of those same problems. And so I think like it's kind of interesting. I've seen kind of the same sort of problems come in and out of focus again over time during my career.
Yeah, that's true. I think as a compiler developer myself, I think we'll also come across the similar challenges. I think the situations will change, the frameworks will change, but eventually the goals would still remain the same.
Right.
And the scale would increase for sure. Yeah. Thank you for sharing that. We have one question from one of our attendees. This is a question from Phoebe Wang.
Okay.
Phoebe says that I'm Phoebe Wang, a trans woman. I'm glad to find this group that is friendly to trans women. I worked on LLVM backend for x86 for 3 years. Currently, I'm still using Pengfei as my name in company and community, but I'm getting stronger and stronger, willing to come out as a transgender to my colleagues and community. I would like to seek advice and suggestions from you.
Yeah, thanks. Welcome, Phoebe, to LLVM. So I guess what I would say is that I have found, particularly the LLVM community, to be quite welcoming to me as a woman. And I guess I've been working in LLVM community since around 2016. And yeah, I would say it's a pretty diverse and welcoming group of people. So, you know, I think, you know, what my sense is LLVM is like really encourages and is like welcoming to a lot of contributions from all sorts of people, and also, you know, with a range of experience in compiler optimization. So I definitely encourage you to, you know, stay involved and, you know, keep getting involved. Go to the dev, unfortunately, I think the dev meeting is online again, but go to the dev meetings. They're really a great place to get to know people. So.
Thank you.
Yeah, welcome. And thank you for asking your question.
You know, I would just jump in and say, you know, one of the things Teresa mentioned was that, you know, at HP, there were a number of women. And it seems to me that at least with regard to gender, we are less diverse as a community than we were back then. So when I joined the compiler group at HP, it was about 30% women.
Yeah.
And you know, I've never been in a group that had that many women. But that said, I would agree with Teresa that I think the community broadly, you know, not just LLVM, but the community broadly is pretty, you know, open and accepting. I do wish we could, you know, see the diversity improve, particularly with regard to gender, but I do think it's a pretty open and welcoming community.
Yeah. And I think that's also is very interesting. I was reflecting on that earlier today, that like, you know, when it was great when I joined HP and there was like Uma and you, Carol, and Anne was around, and, you know, I think we had Linda was the manager of the whole organization. I forget what we were called at that point, but I mean, there was quite a few senior women, and, or, you know, more senior to me and senior to like varying degrees in the organization. And it was really nice. It was great for me. You know, I learned a lot from having other women in the group, because I mean, to be honest, like, you know, I have throughout my career frequently been the only woman in my group or the only woman in the classroom. And you know, but in general, I feel like the compiler community is pretty welcoming, which I've had a good experience being a woman, even when I'm the only one in the room. So I think that it's kind of odd to me that actually sometimes I see less diversity among women now than I did when I first started. But I mean, it kind of, I don't know. It seems like it's not like a strictly linear improvement. Unfortunately, it's like 2 steps forward, 1 step back. But in general, I do find that like I've had a great career because I feel like the community that I work in, and this is one of the reasons why I still do compiler work, is generally been very supportive and welcoming.
So a tangential question, Teresa. So does the imposter syndrome ever go away, and does it get exaggerated when you are a minority in a group?
That's a good question. I don't think the imposter syndrome ever goes away. I mean, you know, I definitely, I think like probably most people, you know, struggle with that from time to time. It's, you know, most sort of like, you know, amazed when I look at like even like people who are then, you know, are more junior, and I like, I mean, their knowledge and their accomplishments are like amazing. So I don't think it ever completely goes away. But like I was saying earlier when we were talking about, I was answering the question about how you feel comfortable asking questions. I mean, I think I have kind of grown in my comfort level that basically, like I said, no one is an expert on everything. Like my knowledge has grown in some areas and shrunk in other areas, and over time, and I mean, I think I've learned to like feel comfortable, you know, asking questions or like, you know, looking for help when I don't understand something. So, you know, it's like never completely goes away, but you sort of, I think, gotten used to the fact that I'm going to be, you know, I'm going to be out of my depth from time to time, and that's okay. And then I think there was another part of your question that
yeah, the second part of the question was, does that get exaggerated when you're a minority?
Oh, yes. That's a good question because I can't answer the perspective from not being a minority. Possibly. I'm sure, you know, it probably is because, you know, you feel that, you know, people might be judging you a little bit more. I mean, I feel like for me, I've been in my career for long enough that I don't worry about it so much. I see it a little bit more. My daughter is in college in computer engineering, and I see those questions in her mind a lot more because she's just starting out, right? It's like the worry of like, do I belong? And so I think it's harder when you're, you know, a woman and you're like, there's only 10% of your degree are other women. It's obviously natural that you're gonna maybe have that worry a little bit more. So I think especially for people who are maybe more junior in their career, their educations, it probably, I can only imagine that that's going to be more, you know, of a something, you know, that they might have more imposter syndrome. You know, I think at some point, for most people, it may get more senior in their career, they're probably a little bit less worried, and a little bit less affected by the fact that I mean, I've been in my career for so long with being the only woman in the room, I don't think about it anymore. So.
Right. Got it. Thanks.
I think the moment when I also particularly realized that this is the imposter syndrome, that itself was kind of a comfort to find out that, okay, this is it. And the next comfort was it is common among every other person, not just, you know,
Yeah.
In women or in the minority groups and so on. But it's still a challenge in itself. It's not like, you know, it just gives you a comfort as in like you have overcome the whole challenge in itself, but it's still a challenge. But it's always good to hear opinions and different perspectives, and then you start feeling comfortable for a while, and then you speak back again those kind of comforting words and motivating words from someone. So thank you for sharing your perspective as well.
Yep.
So this another question. So most software engineering is learned by doing, and compilers though are built on a rich theoretical foundation. So in your opinion, like you also shared that you learned compilers as you came across different problems, not through like a structured way, not by taking courses or something.
Right.
But how do you still feel about, you know, learning compilers for someone maybe who is a beginner or who has not come across a problem where they would want to explore compilers because of their need? So what do you think is a structured educational way, like by taking course, is one of the good ways to learn compilers, or, you know, are there different ways to approach learning compilers?
Yeah, I mean, I would imagine that there's probably bit more hopefully like classes available in like compiler optimizations specifically, because and part of this was because I was in electrical engineering, but I didn't really take, I think I took one class that covered more like Lex and Yak level kind of compilation parsing, and that was really it. And some of my graduate school work had a little bit of compiler work, but it sort of came at it from the architecture level. But I mean, so I learned a lot by doing, and I also learned a lot by reading papers. And I'm not honestly sure if that's still the best way to learn. I mean, I would hope that there's coursework that basically distills some of that down into a level that's a little bit more easily to digest particularly for students. But I mean, I don't really have a strong theoretical background in compiler, like I said, I didn't really take coursework in it. It was stuff that I sort of learned on my own. And so again, I mean, I read papers, so I guess that's sort of was learning in some, but I think that you can basically learn compiler optimization over time, and by picking up that knowledge from a variety of different places. So yeah, that's all I can say sort of from my experience, but yeah.
And I think the tangential question over there was like, do you think formal education of compilers would help someone become a better compiler engineer? And also the another question is like, do you think great programmers are the best compiler engineers in general? Like, do you feel programming does make you the best does make someone the best being in the compiler field, be it a researcher or a compiler developer?
Okay. So for the first one, I mean, I think it would be really good to have actually more formal sort of, and like I said, I have not been in academia for a very long time now, so there may be much better coursework on compiler optimization and compiler frameworks. I think that would actually be really helpful for getting more students involved in compilers. I mean, I think I get the sense that at the undergrad level, it's not very common to have those kind of courses. And it would be really helpful to get, I think more people coming out of undergrad with a stronger compiler exposure. So I think that would be really helpful. So on the programmer thing, I mean, I'm a proficient programmer. I would never call myself a great programmer. I mean, I've been programming for a long time, but again, I don't have a lot of formal training. I mean, I took a class in high school on Pascal, and I took one programming class, I think, when I was starting out in EE, Fortran based, and the rest I kind of just learned on my own. I mean, I'm proficient, but I mean, there's still like, if I look at like really sophisticated C++ code with lots of abstraction, my eyes starts to glaze over. So I guess you don't need to be an absolute, expert programmer to do it. I think it's from the compiler perspective, it is important to be able to understand like what are the, I don't do front end work, but by the time it gets to the IR, you at least want to understand like what are the sort of guarantees and what can you legally do in the optimization world. And so you have to have a bit of language knowledge there, but yeah, I don't think that you have to be necessarily like the most sophisticated programmer to do good compiler work.
Right. So I think it's an encouraging message for all those people, who have been shying away to be a part of compiler community and to be able to compilers. Please join in.
Yeah, definitely.
So do you enjoy presenting about your work in general, and how do you feel that this is important for individuals who may be afraid to put their work on display?
Okay, so I enjoy when I am done presenting my work. I will never be one of those people who can just get up and riff off the cuff on technical stuff. I'm sort of always amazed at people who can put up one slide and talk and talk and talk and talk. It's just not me. And I think at this point it will never be me. You know, I think it's important though to give talks about your work. And it's, you know, even for people like me, that's not necessarily natural. I have to do a lot of preparation and kind of psych myself up. But I'm always happy that I have done it. I think, you know, the process of preparing to present your work, first of all, is very clarifying. It can, you know, cause you to do a lot of critical thinking about your own work that actually is really helpful. And then, you know, just getting up and you know, talking about your work to other people. I mean, you can get a lot of input from other people that, you know, can be really valuable because it might, you know, give you ideas or point out issues that you haven't thought about. That can always be a little intimidating, but I mean, I think usually audiences are pretty friendly, so that's good. And I also think, you know, it helps because you can make those connections in like, for example, doing an LLVM dev talk or a tech talk in your company, you basically make a lot of connections that you wouldn't have otherwise. Yeah, I mean, I also think that it, you know, especially this is important, I think, for like women and other minorities, is like it raises your visibility, and that's also very important and rewarding. So, you know, I find the process of like preparing for a talk a little bit painful if it's not really in my nature, but to do it naturally. But I'm always really happy when I've actually done it because I think it's been really valuable every time. So, yeah.
And how do you keep up with the developments in the compilers world? Are there any conferences, journals, or blogs that are your standard, you know, go-to places where you feel like, okay, this is the time and I should look up and find out new things?
Yeah, and I don't do it as much as I should, but I mean, so I'm pretty involved in CGO, the Code Generation Optimization conference, and so I do read a lot of papers and watch a lot of talks through that, through LLVM. The dev meeting is always really good way to learn about, you know, what other people are working on. And you know, there's various other conferences related to compilers that I sometimes will read the papers or for. I'm not as, like I said, it's something I should do more, that I, you know, I always feel like I should be reading more papers. It's really hard to stay on top of everything though. So I do it when I can, but yeah.
Yeah, that's true. I mean, we can't just approach every single thing, but still we can find a few places. Yeah, there's some other question from the attendees. This is from Mahua Roy. They're asking, how big is the compiler group at Google and how many women are in the compilers group specifically?
Yeah, so it's actually a slightly hard question to answer because we don't have a single compiler group. I mean, so I'm in the compiler optimization group when we do compiler optimization for C++, and our team is growing actually quite a bit, but I mean, we have at least a dozen people now with one other woman as of this week. So that's new because I don't think there's been another woman in that group other than interns occasionally, since I've been there. But there are quite a few other compiler groups at Google. So David Blakey, who's here on the call, is in another compiler group. There's various pieces because the compilers actually, and sort of tooling around the compilers, is used pretty widely by various groups at Google. And then there's like the MLIR team. So there's quite a few other groups, and I can't speak as much as to how many women. There's like, you know, there's a smattering of women here and there. Like any other place, it's not, you know, anywhere near parity. But there's a few women here and there. And the compiler group, like I said, there's quite a few different compiler groups at Google. So I mean, all together is a lot of people, but I don't even know how to estimate. But yeah, compiler optimization is probably like a dozen-ish people just on our team.
So what are some productivity hacks that you have picked up over the course of your career? And are there any favorite books of yours that, basically keep you going in general, or they keep you encouraged and motivated?
I don't read as much as I should. And do my books, I assume you mean like sort of
Maybe
kind of like career.
Actually for the productivity, or maybe some other,
Yeah.
solutions that you have figured out for yourself
I,
and well for you.
yeah. Books, I have no recommendations. I probably should, again, it's one of those things I should read more and I don't. But productivity hacks, I think, for me, just ruthlessly prioritizing. One thing that happened when I went down to part-time, and even when I went back to full-time and I had kids, is like my day was very I had like hard bounds on either end. And so it forced me to get really organized and be really good about prioritizing. And, actually one of the things that would, I don't miss community office because I'm still working from home, but actually one of the nice things about community office, I used to go in really early because I hate sitting in traffic. But I would drive in and like 20 something minutes. And I'm like a list maker. So I was like thinking in my head, like, okay, what do I want to get done today? X, Y, Z, like kind of prioritize it in my head. And of course, something always comes up that's not expected. And, the list goes out the window, but it's, I think it helps to basically help me to just prioritize and like think through, okay, like what are the things I like want to get done? I need to get done today, and just ruthlessly prioritize and be organized. And, nice thing about having the bounds at either end of my day in the office is that I like really, it kind of forced me to focus a lot. So I've lost a little bit of that with work from home. My day is kind of like, I'm sure like everybody, it's kind of expands and it's a bit more diffuse, but yeah.
I mean, it's also important to feel that way, right? Like, okay, it's just not us who, with our days just messed around sometimes, and I think most of the times, and then
Mm-hmm.
you're like, oh, I had to take care of these things, but something else happened, and so on. So yeah.
I mean, so many times when I make those lists going in and I leave work and then I'm like, I got none of those done. So that's okay, because something else comes up, and that's okay. I mean, again, it's just prioritizing very carefully.
Yeah. So in terms of setting your personal growth, be it as an individual contributor or otherwise, how do you like to structure your goals? Like, do you set some short-term goals for yourself, or do you set like, okay, this is my 1 year goal, like a long-term goal or something like that, and then you slowly, work towards it? Like, how do you work towards your actual goals, and how do you set your goals particularly?
Yeah, I mean, I think it's important to have like sort of longer term vision, but also like break it up into really concrete steps. And I also like to have sort of shorter term projects too, just because it gives me that sort of sense of accomplishment that sometimes is missing when you're working on something that's a bit longer term horizon. But I mean, yeah, I mean, I definitely for myself and sort of in our group, what we do is kind of, we have like longer term, like a couple of years out, but then, break it up into like, concretely, like what can I do by the end of the year and what can I do just in the next few months, and try and actually, divide these sort of longer term things up into basically shorter term increments. And especially if you can kind of like, for some things that have a long-term horizon, like an LTO as an example, if you can break it up into like something that I can show end to end, what this does, which I might be able to do much faster. I can do it, more elegantly in a longer term, but finding a way to sort of demonstrate the value of what you're doing in a shorter term, I think is helpful.
Yeah. That's true. And I think that is really important point that you made, like to be able to recognize your progress in a shorter term itself is also equally important, because otherwise having those long-term goals can make us feel that we are lost in the whole, journey, and we don't know whether we are achieving anything or not. So yeah, I think that's super important.
So Teresa, so the geek in me is a little curious about on the productivity hack question. So do you do you have any like workstation setup hacks? Like I like using Clang format, or debugging shortcuts saves me a lot of time. Kind of kind of hacks.
So let's see, workstation hacks. I have it set up so that I basically at home and at work I can can see my same session. So I believe I might have to tweak that given some new information I have, that my setup might be legacy. But anyway, I'll cross that bridge when I come to it. But basically having the same setup, so like when I go home, I can like see exactly what I was doing, and it saves me a lot of time. And I don't know how people can work effectively across home and work without doing that, because a lot of my memory is actually like what I can see on the screen. Otherwise I lose it. And so that's a big one. I have, I have, in terms of like other things, I have like a lot of aliases and scripts set up for things that I do commonly. So I don't have to think about them. I try and script a lot of things. And there was one other thing I was gonna say, I've forgotten. Oh, my email is my big part of my memory. So I email myself frequently things that I think I might forget. And I'm really good at searching my email. So if I lost my email, I would lose half my brain.
Cool. Thank you.
Yeah, I have to document a lot of what I do because I will forget it. And
Okay, a little bit towards the compiler optimizations perspective, we'd love to hear, like, can you share some insights on what is a potential future of compiler optimizations? Like, a lot of research and development is happening in this space. A lot of research papers come out, but we still see, a different rate of actual progress happening in the real compilers. But in general, what do you, according to you, where are we headed next in this space?
So just a couple areas that sort of I'm more familiar with. I mean, I think that we have so much data available to us that we can, so one of the things I was talking about earlier is like this trend towards using profile feedback. And I've seen like more and more types of profile feedback. And also I think using data to use and machine learning on data to actually feed that into the compiler. I know there are a lot of people working on that. And I think actually like the fusion of those two things, like profile and ML, and like basically using this like vast amount of data that we have to basically help the compiler make smarter decisions. I think in the compiler world, there are so many heuristics and sort of things people have like built in based on what they have seen empirically, like these, thresholds and just all sorts of various heuristics that are hard coded in there. And I think it would be good to, like, as much as we can, use, information that we have about how things are being compiled and how things behave, and actually like feed that back mechanically and automatically, I should say, and so that there's less up to like a human having to actually like run a bunch of code and figure out what should this number be, in the compiler for whatever. So I think that's, using the data that we have to like feed back into the compiler is one thing that I see a use of a lot more and more. I also think, and this is not at all my area, but I see a lot of domain-specific languages, and for especially for heterogeneous compilation or heterogeneous computing. So there's a lot of the times these like, custom chips that are being developed on the side and being able to compile for those. I think that's a big area that I see a lot of people working on, but that's not my area, so I can't say a whole lot of really intelligent things about it. But those are kind of two areas where I've seen a lot of people starting to work, and a lot of papers and things like that in those areas.
Yeah, I think these are super important, especially I think I also get fascinated with this fact, like how this shift has started to take place in feedback-driven compiler development. And I think that's really relevant at this time because now we cannot just stick to our traditional techniques of thinking about like, okay, these are the optimizations that we anticipate could be important, or any other techniques that could be important, but it's more about learning from the actual data and figuring out what is going to give us more benefits and so on. And
Yeah.
to be able
And I
to
think we have a lot of data. I mean, I know at Google we have a lot of data because we're compiling a lot of stuff internally, but I mean, even externally, and this is one of the advantages of having a large open source compiler that a lot of people are using. I mean, there's just a lot of people compiling with LLVM. There's a lot of data out there about how things are built. And, I think that you can do interesting things with that.
Absolutely. Thank you for sharing, this perspectives with us, these insights. They are super valuable, and I'm sure like these would be some ideas, which one can actually pursue towards, doing some research also in the future and find some collaborations in the open source community.
Yeah, I think there's a lot of stuff. Yeah.
I think there's some other comment or question from somebody.
Yeah, and we talked a little bit about this earlier. So yeah, my undergraduate, I didn't really learn compilers at all. I think, and I'm trying to remember, I never learning Lexemiac. That was it, and that was what I thought compilers were. It was very boring. It was probably part of some, I don't even know what class it was, but so I really didn't learn compilers until I was in graduate school and I was doing research, architecture research, and we needed a compiler to compile for that architecture. So I really think that it would be really good to have more exposure to compilers in undergraduate. And like I said, I don't know if that maybe that's improved, but we don't see a lot of people coming out of undergrad with compiler expertise. I just know when we try to hire, it's usually people who've been in grad school in some fashion, or who have built up that knowledge through time in industry. It's there's not that many people who do this as part of their undergraduate education. I think it would actually be really helpful because there's quite a lot of interesting problems in the compiler space, but it's hard to find people who have that experience. So yeah, I think it would be really valuable. And yeah, LLVM specifically is any open source compiler, but LLVM specifically is, I think, something that is more beginner friendly and that people can actually probably make some contribution to as an undergrad. And I think it helps that there's like a pretty big community of people that actually are, I have very occasionally worked with undergrads, and I think that there's a lot of people out there who you can ask questions to if you're a student who's just starting out, which is really helpful.
And then there are different programs for someone who doesn't know. Like you can participate in Google Summer of Code, and over there there are different LLVM projects that come out, and then there are other internship programs with this LLVM Foundation, so that you can participate in, and that is also another way to learn LLVM, because it's harder to learn the whole LLVM compiler in itself. I also don't know. It's just like little parts that you try to learn those and work on. Are there more questions? If there are any further questions, please feel free to ask now. Otherwise, I think we'll wrap up our session. Cindy, Anupama, are there any more questions that you would want to bring up?
I think I'm good. Thank you, Teresa. This was great.
Oh, thanks. Yeah. Yeah, thanks for inviting me. It was, and I always feel a little funny because I've done a couple of these types of sessions because I still feel like I'm kind of, I mentioned this earlier, I'm still kind of bumbling around. I'm still figuring things out. So, but I have been around for a little while now at this point. So I'm happy to pass along whatever it is that I've learned that could be helpful. But yeah, I think one thing you find out when you've been in your career for a long time is it's a journey, and it keeps, changing, and you keep learning. And So.
Yeah, absolutely. Thank you so much for coming and for sharing so much knowledge with us and so many different insights and perspectives with us. It's
Thanks.
super, valuable for all of us to learn even a tiny bit from today's session and take it with us through our careers and life. Thank you so much.
Thanks for having me. Happy to do it. So yeah.
Okay, all right. I think we'll see you all next month in our October meetup event. And thank you all for joining.
Thanks. Okay, bye.